Okay, so let's get going. So today's lecture, I'm going to be hitting on a couple of topics, but the major one I want to touch on is one that that bears some thought right now in your projects. It's something which you want to design in from early on. You want to have frameworks in place to support it, and you want to think through how you're going to use it in the course of the semester. And in as much as you're setting the architecture of your system up, you're establishing plans for your continuous integration, you're establishing the tools you want to use, it bears to think about a lot, and that is the issue of testability. Programs differ widely in the degree to which we are able to test them effectively, particularly in an interactive and in an automated way. There's a great deal of value that comes from black box testing of systems. What do I mean by black box testing? Anyone?
Doesn't matter how it's implemented, it just matters what it's inputting and output.
Good, yeah, that's right. So you're not concerned about the details of implementation. What you're really concerned about is what it does, and you're sort of verifying that it performs the actions it's supposed to accomplish at the level of the what, and you're not worried about the how. Now, black box testing can be applied at many different levels. It can be applied at the method level. You deal with the inputs, outputs, you deal with the specification of the code. All the way up to being applied at the level of the entire system. What would it mean to test the system in a black box way if you were thinking about a system as a whole? Well, maybe it's a web app, for example. Yeah.
Given certain clicks on the screen, I will want to see this screen with this text on it.
Good. That's excellent. So yeah, the inputs there are user inputs, particularly, although maybe inputs that are triggered by other actions, of an outside environment as well. Maybe your system is supposed to respond a certain way when email comes in, or maybe data is arriving on an ongoing basis from sensors or something about the environment, and you want to know, is it responding properly in those cases? Once again, you're not going to the details of the implementation, every detail about how it's implemented, but you really want to know, is it fulfilling its requirements in terms of what it's accomplishing when these things happen? When the user clicks here, when the user presses this button, when the user goes to this other screen, based on they haven't logged in yet, or they have, or what have you, is it behaving properly? Does it do the right things when you go offline? The connection is no longer available, etc. Right? These are aspects of black box testing. And that can get us quite far. And you will be expected to undertake a lot of that black box testing. That's what you'll be doing in bug parties for a lot of the time. It's what I'll be doing in coaching your software, etc. So that's good, and it's to be expected. But ladies and gentlemen, particularly when your system is complex, particularly when it isn't working properly, and you want to understand why, particularly when you're interested in testing pieces of it. You're interested in understanding, is this module working correctly? Or are these three modules playing together nicely in the appropriate way? We often have challenges probing that. Even if we're looking at input-output behavior, sometimes we want to develop confidence. Is it, in fact, doing the reasonable calculations on the way to get us those input-output behavior, right? Is it going through the necessary steps, checking the conditions? Hopefully we'll be able to determine something about that by giving it various test cases. But often it really cuts to the chase. If you could know halfway through what it's doing, like what things is it checking, what things is it doing along the way, that will often get you a degree of insight about, is it working properly, or why is it not working properly? That's key for debugging, but it's also key for developing confidence the system is in fact working properly, right? Think about an airline. reservation system, right? You go and you request, a flight from Saskatoon to New York City, and it comes up with some answers, but is it really searching the full set of possibilities? Is it going through the various connecting cities? You may be able to see a number of them, but you really like to know along the way, what is it doing to have enough confidence it's working properly, okay? And these things, this ability to kind of know along the way what's it doing, not only is it important, but it's often hard. It's often hard to observe unless we engineer it into the system. Hence this notion of testability of a system. We talk about the modifiability of the system, the transparency of the system, the performance of the system. But another component that really matters is it testable? If it's not very testable, it's going to get in the way of finding issues. So you get in the way of debugging those issues. And testability is something that doesn't fall out of the sky. You have to plan for it. And it's not just a matter of one thing. It's a matter of a bunch of things. But a lot of those things are things you have to start planning for up front. What's something that could help testability? Help it make it easier to be able to test your system? Anyone? Yeah.
Logging.
Yeah, logging is a great example. Superb example. If you log, and particularly if you log in a multi-level way, it'll be much easier to diagnose what the system is doing, what the system did to accomplish some task, and you can look and check, okay, did it go through the right steps? Did it in fact look this up and get a result? Did it go through this key part of the process, etc.? And that's really valuable. But I note that I emphasize the multi-level logging. What do I mean by multi-level logging? Yeah.
You would have more granular logs that would be hidden by default, but accessible if you needed them.
Excellent. Yeah, that's exactly right. So, ladies and gentlemen, look, we all know, and maybe some of us love, putting in place kind of naive logging, right? From some of the very first programs we created, we had print statements that printed out certain things along the way and gave us confidence it was actually doing the right thing, or helped us figure out where it was going wrong, where it went wrong, right? And that's great. But you know what the issues were with that, if you reflect on it, right? One thing is you have to put them in. And that doesn't, it's not trivial. I mean, you have to go think about where these things have to be and scatter them in. Often you put them in over time as you're debugging. And then at the end, you got to do what? You got to remove them. And then the next time you're confused about whether it's working, you might put some more in. Or maybe you leave some in there, but before you hand in the report or hand in the assignment, you have to remove them, right? And that takes a lot of time. It's awkward, might be inconsistent, you don't put them in the right places. And what you'd really like to be able to do is flip a switch and say, log this at this level, and then at other times say, hey, throttle back what you're telling me. I don't need to know all those details. Just tell me the high level gist of what's going on. And then when you're debugging, hey, now give me lots of information about what's going on, because these next few steps are critical. You'd like to be able to do that without recompiling, without having to go instrument your code with all these things many places. You'd like to be able to do it on demand, dynamically, meaning no compilation, just sometimes you throttle it up, sometimes you throttle it down as you're running it, as you're exploring, as you're testing. So logging is a key technology, and logging in a multi-level fashion, as is well supported by many types of environments now, many types of frameworks. What's another thing that will make your program easier to test?
Designing with dependency injection in mind.
Good. Designing with dependency injection in mind. So amongst other things, dependency injection a technique for allowing decoupling of what particular components elsewhere in a program are running from this component of of specific interest now. So allowing us to use component A, and it may be used with B or C, or it may be used with mocks of B or C, as substitutes for B or C, or what have you. This is one way to sort of decouple those components of a program, which might allow you to slot in other implementations. And in general, mocking is another closely related thing. How about another thing that helps testability? Separation of concerns, ladies and gentlemen. Does that term mean something to you? What does it mean? Give me some sense of what it means. What does it mean for a program to exhibit separation of concerns? Okay, model view control is an example of separation of concerns. We have a component of a system that's devoted to sort of the business logic, the kind of the core logic and domain-specific concepts and so on. That's sort of the model, often captured with classes and so on. And then we have a view component that displays and renders and visually represents or otherwise reports on those components. And then we have a controller component, which might be associated with UI clicks and keyboards and buttons and all that sort of stuff that we would press. So that's good. That exhibits separation of concerns. You have these sort of three domains. So that's an example of it. But more generally, what does it mean to have a separation of concerns? Yeah.
For each functionality, for each type of functionality, there should be exactly one place we have to look for to make changes and apply.
Excellent. Yeah. So we have different needs within a program. Some needs are more for the UI, some are for the back end, some are for database level stuff. Some are for issues having to do with the application logic, other more business logic, sort of domain logic. Some might have to do with the interface to the network or what have you. And each should have its home. Each should have its own area of the system that deals with those issues. Why would that help testability, though? So it sounds good. We can have different people work on it. Why would it help testability? Yeah.
There's only one place we have to go and test functions for.
Good.
And we can always remove the whole component and put in a mock part of the component.
Good. That's a lot of it. You folks are on top of things. That's right. That's a big part of it. We could do mocking, and mocking helps a lot because we can slot in a fake version of this which returns fixed values or double checks the inputs given to it, or does things in a very well-defined way from a database so that we don't have to worry about issues there, and we're focusing on other components that interface with that to see if they're working properly. And we know exactly what's being given to them, and we know exactly what they're telling this mock component, and it allows us to zero in the issues early. So that can help testing big time. It can help debugging. That's great. And another thing is the tests for those areas of the system are easier to write because often it's one technology, one set of concerns, one interface for it that has a well-defined interface, well-defined contract associated with it. And we can engage in the contract as a user and see if it does the right things. Without, and this is the key point, without having to test the system all at once. Ladies and gentlemen, perhaps you are innocent to the experience. Perhaps you have not been subjected to the suffering caused by trying to work with a complex system as a whole and having to test the whole thing together at the same time. So one of the classic anti-patterns of this, I don't know how many of you have taken 350 or done web app development. One of the old anti-patterns dealt with exactly that issue. In the early stages of the web, there's a proliferation of websites backed by databases, much like there are today. And like today, they had UI issues. They had issues that had to go on in terms of the business logic, and had to go on in terms of storing data, for example, taking user input, displaying it. And all too often back then, it was all mixed together in a hairball. It was a code hairball. It was just tangled together. UI stuff, database stuff, issues having to do with the kind of business logic. And to test any one piece of it, you have to test the whole thing. Because where was the business logic? Well, it was mixed with the UI. How do you test the business logic without the UI then? You don't. You have to test it through the UI. How do you test, the database layer stuff? Well, there's no layer there. It's you're testing it through the UI. Is it retrieving the information, putting it in only in terms of how it displays in the UI? It's a big hairball. To test any one piece, you have to test all of it. I quoted King Lear to you before, and sometimes I'll engage in other areas of Shakespeare, but I'll go back to that quote from King Lear. That why, ladies and gentlemen, lies madness. If you can't test one thing without testing the whole thing, you're hurting. Because after all, you need to focus your tests. You want to test against specific features of the situation. And if you can't test anything but the whole thing, it's hard to test the intermediate values. It's hard to know, is it doing the right thing along the way? You're basically stuck with black box testing of the whole system. And a lot can go wrong between the request and the result of the whole system. So ladies and gentlemen, testability matters. Testability needs work to achieve it. Testability is fostered by many technologies. We mentioned some of them here. Logging, and separation of concerns, issues having to do with having well-defined interfaces. But there's many others. Use of assertions, use of specifications also help. Designing a system to be modular. We talked about mocking earlier, and that's a key component of it. These are just some of the pieces. Now, we have to remember that testing here is a process of more than just finding bugs. It's a process of being able to sense which areas of a system are robust, which areas of a system are weak and need more testing. And so because of that, user-driven testing is very important. And user-driven testing can also benefit from these sort of strategies for testability. So I've listed up here some benefits. Some of them we haven't mentioned yet. Good documentation can help. What is the system supposed to do? It's kind of hard to test in a black box way if you don't know what it's supposed to return. Right? How do you test that it's working if you don't know what it's supposed to do? Is the answer right? Is the answer wrong? Did it do it properly? It's not clear. We talked about separating interfaces from implementation, associated with dependency injection, for example. You can have a dependence only on an interface rather than the particular details of it. But one thing I'm going to be emphasizing here is also hooks, test hooks. Some of you are working with systems that are hard to test, harder to test. An example is the Oculus system. It's not trivial to test in an automated way whether a system that involves 3D views and so on is working. It's not like a web app where you could tell, system click here and this should appear, and then you pull down this thing from the drop down and select this, and this page should appear, etc. Testing something like the Oculus with a 3D interface requires extra level of ingenuity, and I mentioned that actually on Tuesday, that you're going to need to be thinking, and test hooks are part of that piece. Okay, so the goal here is to ease the lives of your testers, and in fact programmers' lives, in as much as there should be testing their code. And a lot of the issue is programs have a large amount of internal state. They have a large amount of sort of status of what's going on while they are running and handling requests. And often you can only access small bits of that. It's like looking at the world through a straw, through the UI. It exposes a very small fraction of total information. Total information about what's happening in the system. And it can be difficult to determine cause for errors because of this. It can be difficult to determine if an error is in fact occurring. A system, you request something, and the system takes the request, and you change some setting, you say okay, system shows you. You actually don't know that occurred, right? I mean, think about it. Students, they often, when they first start thinking about testing, they're trying to make sure the program doesn't crash. And that's a good start. I don't want to belittle that. That's a good start. That it doesn't crash is something. Much rather you have clarity about that than you just assume it doesn't crash. Because it probably will crash a fair bit for early contributions. So that's the start. But the fact is we have to check a lot more than that. We have to check that it's in fact doing what we requested. And if you just change the setting and you say, okay, it doesn't crash, that doesn't mean it's accomplished it. To confirm that, you would have to go back and check, say, the setting again and see that it's updated, right? Or you do something that depends on that setting. Maybe you check that, maybe you change the setting for zoom and now you confirm, okay, it's zoomed out. Or maybe you change the setting for what the default font should be, so you have to create a new document and see, okay, is the default font set to that, right? Does that make sense? You have to be able to check that it changed something. You also want to check that it didn't change certain things, that it didn't, say, alter the font immediately. That involves also further exploration. So the point here is that, ladies and gentlemen, we want to be able to test our system in ways that are more rigorous than just seeing whether or not it crashes. We want to understand something about what it's done, be able to confirm what it's done. And often that's hard to do through the UI or cumbersome to do through the UI. We'd like ways of gathering that information in a way that's easier than just having to go do it all through the UI. And so we have to consider how the operation of the system, like what state the system's in, did it change something, is revealed to testers and developers. And what I'm getting at here is sometimes pieces of the code that have a certain interface for other areas of the system, they need a different interface for testing. A different interface that's revealed for the sake of testing, so that you can peer in and say what's going on. Maybe if I'm testing the Oculus, I'm doing so a lot of the time manually, but I'd like to be able to have a hook where by pressing the right combination of buttons on my controller, or what have you, by bringing the point of active control to a certain point, I can get extra information on the state of the system. I can get information on some calculations it's done, or what scale it's currently using. Those are not part of the user experience, the end user experience, but they might be part of the tester experience. Do you understand that point? And it might be part of the experience developers want to debug the system and to quickly check what's going on. Okay? So here we're talking about different interfaces for things like logging and things that provide information when we're debugging, when we're testing. So you should be thinking about, when you're designing your system, when you're sort of figuring out what contracts, what software contracts, what specifications have for different pieces of the system, what are the methods that need to be supported by this? You should be thinking, what are the methods that are needed for the rest of the system to be written, but what are the methods that are needed to help debugging, right? You might have a method, maybe you have a complex data structure. Maybe it's a dictionary that has a key role in the system. And you want to be able to ask, does this dictionary contain any duplicate keys? Does it contain any values which have null values in? you want to be able to test, what's the length of the smallest key within the system, or what have you. Check that everything in the system has a key of a certain structured form. These are things that are put in place not because the end system needs them, but because we want to develop confidence it's working. We want to be able to have tests that will test things out. So, modularity, use of specifications, which I've requested. We'll talk more about this quite possibly next time. But basically, these are things that describe for a given method, preconditions, postconditions for that method, what it needs to do its job in terms of preconditions, say values of parameters passed to it, and then what are the postconditions? What are the things that, when it finishes running, what are the things that are guaranteed, or supposed to be guaranteed by this? Maybe it's the return value is some function of the input values. Maybe this part of the graphics pipeline has been modified. Maybe it's an email has been sent. Whatever the post condition is, you specify what that is. That's a specification. That's specifying what this method is supposed to do. And if we have that specification, it provides a guide for whom? Having that specification of what this component of the system is supposed to do, who is that useful for? Anyone give me one example of someone it's useful for, besides myself? Yes.
Testers.
Testers it's good for. You bet it's good for testers. Man, they don't have to go through all the pieces of the code and reason, okay, what is this supposed to be doing? What is this code doing? What is it supposed to accomplish? What are the important things here? Instead, they have a sense of what it's supposed to do. And they don't have to get into exactly how it does it. And maybe that changes it. It's good they don't have to get into that. So for testers, it's great. Who else is it good for?
Developers that are wanting to use that.
Yeah, developers who want to use it. You got it. Really helpful for them because they know, okay, what's guaranteed, right? If I use this thing, what can I count on being the case? They don't have to go into the code and guess, is that really guaranteed or is that just an aspect of its current situation and always returns it in a sorted order? All they care about is having the first element of it that matches some criteria, but is it always going to be sorted? They don't have to worry about that because it's guaranteed by the contract. Just like if you have a contract with a company to accomplish some tasks, you don't have to worry about who they assign to that task. You just need to know that they will get this work done by this time for this certain amount of money. And you don't have to worry about all the vagaries of how they get there or who's going to be on shift this time or whatever. It's all just defined at a higher level so that you don't have to worry about all those details. Who else is that good for? Testers and developers, key components then. Or what else is that good for? Contracts. Well, for mocking, right? Yeah.
For the stakeholder to review before the implementation.
Yeah, sometimes for the stakeholder, it's going to be interested in that too. That's right, particularly for higher level components. So that might be of interest because these specifications could be given at any number of different levels of the system. So that's good. So specifications provide us with a lot of things that can enable testability. They can enable also peer review. Another area where it's really good, right? We can have a point of reference so when we look at the code, we know what it's supposed to do. Okay, separation of interface from implementation. Why is this so important? When you think about mocking, for example, why is it so important we have a separation of interface from implementation? That if we have a class A and it depends on other things, that it's not depending on the particular classes, B and C, it's depending on an interface that those classes implement. So it's depending on B and C here. And why is it important that it be operating through an interface? Why is it valuable? Why does it help? Testability. If it's depending on class B, well, for separation concerns, it's good. But why is it even better if it's operating off of an interface that class B happens to implement?
So you could just substitute out any class that matches that interface.
Yes. Good man. Good man. So, ladies and gentlemen, if it's operating to be through an interface, this is the particular, B class, but it's really operating through an interface that is, the B interface. And any class can be provided that matches that interface. We're not dependent on this specific class, and that allows us to, amongst other things, mock this out, substitute an alternative sort of implementation of this, evolve this to a different class. In more sophisticated contexts, like where we have dependency injection, where we have a mechanism of having in place a sort of declarative way of saying this is the implementation of B to use, like in a text file that we can change. We'll use this implementation of B for this time in a config file. It provides that extra level of flexibility there. But going through an interface supports mocking well. Okay, harnesses and drivers. So you're going to want to have components of the system. We talked about this a bit last time, or I certainly alluded to it. You want test harnesses that will drive the application programmatically. It will call methods in the application, probably similar methods to what would be called through the UI if you were using the UI, but that will be putting the application through a series of steps, right? These are test drivers or test harnesses to have it undertake steps, and you may test it repeatedly over a large number of different inputs. You've seen this quite a bit, I think, with JUnit. At least many of you have seen it with JUnit. Ladies and gentlemen, hooks. I talked about them earlier, to expose functionality for the sake of testing. These are not methods you're going to expose for the rest of the system, but we want to be able to say, hey, what's in this class right now in terms of what values does it hold? So I don't have to check everything through a dialog box in the UI. I can actually ask, okay, did this store the right value, etc. And it might allow me to sort of drive the application. In some cases, put in place a fake error message. Okay, so you want your system to be able to handle out of disk space errors. You want your system to be able to handle corruption of a file. You want your system to be able to handle a disk error. You want your system to be able to handle some unusual network error. We want our system to be able to handle a case where the network fails, where there's a DNS problem. All these might be cases you want your system to handle, but we don't want to have to actually have, not all cases though, do we actually want to force the exact physical condition to be in place. I mean, to have a disk error, do you really want to take a hammer and wail on your disk to see how your program does? Well, okay, maybe some people do, but I don't. And you'd like to be able to sort of see how it behaves by causing an error artificially of that sort and see if it does the right thing. Gives the right user message, maybe logs some information via HTTP, maybe it responds in a way by indicating the user the system is currently unavailable. But to accomplish that, you don't want to have to cause a literal disk error. You want to be able to cause it in a different way. So this is part of the idea of a hook. I want to be able to hook in to this piece and drive an error. Okay? In some cases, some programs, they have scripting interfaces to allow you to sort of programmatically go in and query the system, like what's going on in the system, and change state underneath it to figure out if it's working well. So assertions. Why do assertions help testability? Anyone? Why does having an assertion in your code aid testability? What is an assertion's job in life? Yeah.
To halt the compilation, break the compilation. So the compiled code is assured to be doing exactly what the assertion is testing for.
Okay, I like many aspects of that answer, and fundamentally, an assertion is something that a programmer puts in place to ensure that their assumptions about what's going on right now are met. Okay? So I'm asserting that when I'm writing this code, you should have it be second nature. If you're making an assumption about what's going on at this point in the program, maybe you're assuming this parameter passed to me is non-null. Maybe you're assuming it's the last item in a linked list. Or after a loop, you've assumed you've got the last item in the linked list. Maybe you are assuming that this dictionary passed to you has no repeating keys. Or maybe you're assuming that this dictionary passed to you has no key in it right now of the sort you're about to insert. And logically, you think this should be the truth, should be the case, in terms of your reasoning. So you put in something that will check that operationally. What do I mean by operationally? What I mean is when the code runs in testing mode, it will actually confirm whether or not this is the case. Do you get that point? So I'm putting in something here to operationally check my assumptions about what's going on at this point in the program. Do you think those assumptions could ever be wrong?
The specifications are wrong or misunderstood.
Darn right. The specifications can be wrong, ladies and gentlemen. If there's someone in here who has done lots of programming and never made an assumption that is off base in terms of, their understanding of the situation, never had their reasoning be an error, come talk with me. I've got a good job for you. But the fact is, it happens, I think, to all of us. That we overlook things, we make mistakes, but more to the point, it's not just what is the case now. It's, remember, code evolves. And maybe our assumption is perfectly valid right now. But as this code evolves, as new features are added, as new extensions are made to the system, as other people add code elsewhere, maybe an assumption which is absolutely grounded, absolutely sensible, absolutely the case when we first put into place, first put that assertion in, maybe it stops being true. Because now the system has to do more, it has a bigger repertoire, and this is no longer guaranteed. And that assertion we put in 6 months ago suddenly fails. Is that possible? Yeah, it's possible. And yeah, people can misunderstand the specifications, they can call it an error, they could ignore the specifications, and they could revive code that was buggy from before and now it's come back. Could that help testing? Yeah, it can help testing because it can help find failures you otherwise wouldn't have noticed, or help find faults you wouldn't have noticed, find cases where the system is not working properly. And importantly, it helps you find them closer to the fault, the underlying mistake. That code might have gone on for quite some time before the user saw an error box with a warning sign. It might have gone on for quite some time till the system failed. But because you have assertions at many places in your program, you find it much closer to where the problem originated. Do you understand that point? I sense the fact that I'm not being animated enough. And I'm not sure how to safely engage in higher levels of animation. I mean, waving around tables is probably not something I want to engage in. Okay. So let's talk about a few more aspects of testability. Stubs mock states. We talked about that earlier. Returning hardwired results, for example, or double checking certain assumptions. And in some cases, you can have implementation at a higher level, sort of mock objects at a higher level that are hitched up to the UI and that you use and test in a way that simulates the system, and you see if if it's working properly. In other cases, you allow for setting the state of the system via a config file, which will not be in fact available to the user, but it will let you get the system in a certain state for the sake of testing. Do you see what I mean? Like if I have a system that's, let's say it's based on the Oculus, and I want to be able to test something with it, do I really want every time to test that to have to go into the system, engage in this behavior, engage in that behavior, rotate it in this way, scale it in this fashion, highlight this many points manually? It's going to take a lot of time. It'd be much better if I could have a config file that would just say, do these actions, undertake these actions, put it into a certain state, and then I can undertake certain well-defined tasks. So think about that. So test hooks. You should be thinking about getting in place test hooks that require often a small amount of coding. They're created by developers for the sake of assertions, etc. And they often improve the debuggability, spotting issues as soon as possible, and sort of integration with third-party code, potentially testing features in the state of the system. So here's some ideas for test hooks. Inspecting internal state. Is this data structure? Is this sort of element of state structured properly? Does it match its invariants? These things it's supposed to guarantee, like that it has no duplicate keys in it, or that it's sorted in a certain way, or what have you. Test hooks may be put into place, for example, for checking the integrity of the system or the consistency. So maybe you have a system where it has a complex algorithm, and you believe you have a good implementation, a savvy, efficient implementation of an algorithm. Okay? Great. But maybe often when you have a savvy implementation of an algorithm, there's a corresponding brute force algorithm. Does that mean something to you? A brute force algorithm? It's just incredibly naive and obvious how to go about it, but it's incredibly expensive. So it takes brute force. Okay? And often it's prohibitive. It's too expensive to undertake. So here, you might have a test hook. Even though you're not going to use the brute force algorithm, you put in place a test hook to undertake the brute force algorithm. Why would that help? Why would you have a test hook to undertake the brute force algorithm? Yeah.
To test that other implementations of the algorithm will provide the same correct results as the brute force one.
Good man. Remind me your name?
Nick.
Nick. Yeah. Nick's exactly on the ball. That's normal. Much appreciate your responses. So, ladies and gentlemen, your assertions might want to use the brute force version of the algorithm to compare with the efficient one. So you have an assertion that's not merely, is this reference non-null? Or, is this data structure empty? Or something like that. Confirming the sort of sanity, the basic sanity situation. You might actually you might have an assertion that compares two algorithms. And you might say, well, what's the benefit? We have the full cost of the brute force implementation. Yes, during testing, you have the brute force implementation being used. During some of the testing. And then you flip a switch and you disable that assertion. And it's not using it anymore. I don't know how much you've used assertions. Are you aware of the fact that with Java, assertions are well supported by the language? There's actually an assert construct in Java. Do you know that? There's an assert keyword. It provides a condition to check and a message associated with it. If it fails, it will indicate, okay, I failed at this thing according to a user-specified message. It will throw an exception. Okay, but more than that, ladies and gentlemen, and this is key, mark my words. You can enable and disable assertions in the compiler. More than that, you can enable them and disable them on a per package basis or per class basis. So I can say turn off the assertions in this class, keep them on in that one. So it's very fine-grained. You could say basically, essentially, you could put the brute force algorithm assertion in a certain module. You have assertions on for it for certain modes of testing, and then you basically say disable that assertion for other parts. And that assertion is eliminated from the bytecode. It's gone, babooshed. So yeah, it's gone, okay? And it's cut out of that code, and it will not run. And then, when you need to debug more, you need to check further things, you might turn it on again. So it provides this very fine-grained way, similar to logging, similar to the config files we have with separations, for systems which use dependency injection. We can just change a config file or change a setting, and now we'll be running it with extra levels of checking. Testability, ladies and gentlemen. Testability. Testability, I tell you. Okay? So diagnostic routines can be useful here to check the integrity of the system, make sure things are sane, things are consistent, etc. And believe me, these things add up. Any one might be unlikely to fail, but you start having thousands of assertions in your system, hundreds of assertions, and you're going to find a lot more bugs you would not have found. And you're going to find them more quickly, and you'll be able to debug them more quickly, because you'll be able to catch the error soon as it propagates through the system. Ladies and gentlemen, so many cases where our systems go awry, we don't know for some lag. And that lag kills us when we're debugging, because the actual error is over here, but by the time we notice it, we're way over here in the system. And it's hard for us to know, where did this come up? And you have to go and drill down and down and down. If you can have assertions all along the way, it'll stop it very close. And it'll allow us to zero in on that error and fix it in a time much quicker than if it had just propagated up and we see some weird error message in the UI. Do you understand my point there? I would hope that at this point in your education, you've been through that experience, checking, trying to trace down errors that come from who knows where in your system. And you could find a real advantage, have the conviction that there's a real advantage if you could find it close to its source. I see some Neds nodding, hopefully not all from fatigue and ennui. Okay. So you want to weigh programmatically driving the application, reading the state of it, etc. Okay. I think we've made this point further. Here are some ideas for UIs. Find the state of the connection to the system. You want to know, is the system connected to the network properly? Have a UI, have a test for it, right? Request the amount of data you've sent thus far. What's the state of the cache in the system, or one of the caches? Report back information on the database tables. How many database updates have taken out? What locks are in place? Checking invariants for data structures. Browsing internal data structures. Enabling of logging of connections or memory usage or keystrokes or commands executed. Number of times you've gone to the database, etc. This is really useful information to let you have conviction. Is the system working or not? And if not, where's it failing? Put these in place early, put them in place often. Not for my sake, ladies and gentlemen, but for yours and the stake of the stakeholders. Okay. I mentioned here is forcing additional error conditions, forcing early end to connections, simulating long connection delays. Seeing if your system times out properly and handles that, etc. All right. Logging is a key technology here, and multi-level logging is much more effective yet. Right. Key technology. Is the capacity to automatically collect cases of system failure from wherever they occur and report them back to the mothership. Okay, so people are using your app on their smartphones. The app crashes. The app has some issue with being able to undertake an action. The app is unable to correctly invoke some system call. The app is unable to report back some information to the main database. The app encounters some issue with parent data corruption. It's counting on something in the data being a certain way and it's not. Report those information back, not just with logcat, not just with the built-in sort of logging here. Report them back to the mothership, to a server via HTTP or HTTPS. Post them back. Why would you do that?
If somebody's testing with a device that none of your testers have access to and it keeps failing,
Yeah.
then you can find out what device is failing on.
Yeah, you want to know about that. If it's a real user, you want to know even sooner, right? Because you want to be able to reach out to them, and you don't want to lose them as a user. You want to be able to figure out, because their case may be emblematic of a lot of cases, and this is your key towards turning around what could be a very dissatisfied user to a satisfied user by nipping this in the bud. So if you're running a small company, as I do, or if you're dealing with users around the world, as we support, I mean, this is golden. If you could know about the problems people are encountering early and be able to respond to them and be able to patch things and be able to suggest that they put in place a patch or they get the latest version of the software, what have you. It's key to be able to know what failures are occurring where, on what devices and so on. So I asked, why do this? But I'd ask instead, ladies and gentlemen, another question. Why not do this? I mean, it's so easy to do. And maybe not trivial, you could argue with reason that there may be some types of errors, like connection problems, which are going to get in the way of immediately sending an error report as well. Fair enough, but look, we're third-year students at the least here, right? You should be able to put in place a mechanism which queues things up so the next time a connection is in place, you send it back, right? Okay, so maybe right now you have an issue, but at some point ET gets the phone home. At some point it gets to be posted to the server, okay? When it's next connected or whatever, you post the error messages. The other thing is it possible someone could be testing your application, even in your own team, and not tell you that an error message occurred?
Yes, if he's testing it too quickly, or if he thinks the problem is and fixes it before and we are trying to determine what the actual problem might be.
That's right. Or it may happen it happens in the middle of something, they didn't catch the error message, so then they did not feel they're able to put in a meaningful bug report, and so they don't end up not reporting it, or maybe they're too busy, or they think they'll mention it and they don't. So, and often these bug reports can report things that are tedious for a user report, like a full stack trace. And they can report things about the nature of the device, the time it occurred, what other apps were running potentially. Android has some restrictions on that, etc. So they can provide all sorts of good info about what's going on. You might even add these things automatically to your issue tracking system, right? This is really valuable stuff, and it should be things that you do. Maybe you even want to know when it crashes for me. Oh man, Oz good at it. Qualified phone. Doing weird things with this. We've got to support that next time. Or you put out a patch, lickety split. Okay, talked about mocks and mocking. Broadly speaking, there are distinctions among classes of things that sort of hash to the same bucket, in the sense that they're fake versions of things that are doppelgangers for the real version. They kind of substitute in for as if they're the real version. but they undertake different actions. So I'm going to distinguish here between when I was a young man, we called them Stubs, okay? Their name was Stubs back then. Same basic idea. They were kind of fake versions of something that did basic things to let the rest of the system do its job, but they wouldn't do the full job of the code that was normally there, and they might check a few things in the process. They're sort of placeholder code, often put into place while you're building the system. But beyond that, there's fakes and mocks. And fakes are sort of particularly simple version of mocks. Mocks often do things like they check the context via assertions. They'll confirm the things passed in are correct. They'll help confirm that this given method has only been called once. It's never been called before this current time. They might log things, etc., rather than always just sort of returning most trivial values. And you're using these in integration tests and unit testing. You want to test A without testing B and C. Our systems are made up of interconnected components, but to test them effectively, we want to have at least some of our tests focus on each component in isolation. And how do you isolate something that depends on other things? You mock those things out. And so we're operating on this, and these things do fixed things. We know what it is. And so if a problem comes up, we know where the problem lies. It's right here. And if we're debugging, we're trying to narrow in on where the problem is. Maybe we have a hypothesis that it's in A. We mock these out, and we see if we can still reproduce that bug by just focusing on A, right? A is the only real code running. The rest are mocks. We're doing unit testing of A. Maybe we're testing the UI, and we want the rest of the system to be mocked out in a sort of regular way so that we can see the UI operate with respect to known interactions, etc. So you folks are using different mocking environments. Jest, I think someone's using JMock. There's JS mock for JavaScript. Quite a few frameworks out there that allow you to do this, Makito. JMock, as well as some other frameworks, I believe, allow you to set expectations with respect to a mocked class. So the idea here is that you can state declaratively, you specify what you want in terms of the mock testing, the ordering of calls, like this has to be called after that. So you have to call the init call before you then call these other methods, for example, right? Or what to do when called. You could say when called, return this. Return this sort of value. Or you can specify a maximum, minimum time that can be called, etc. And it's checking these. So here's an example of a use of JMock. So here we create a mock of a certain class, and this subscriber now is a mock, and it's going to be testing certain things when sent to it. We're sending it messages, and we're testing, is the system working properly? So here you can see the mocking occurs at a single line here. And then we make use of the mocking down here. We're sort of checking that certain expectations are met. And these are some of the examples of expectations we might want to check. We might want to confirm this thing is equal to that. This argument is equal to something. Or that it's the same object as pointed to by this other argument. You want to confirm that this certain thing is null, or that it's an instance of a type, or that it's not null, etc. So in JMock, you can specify declaratively for this method or this class, check these expectations. Make sure these expectations are met when these things are called. And by so doing, you might spot errors in terms of how A is doing things with the mock that you've put in place for C, for example. Okay, I talked about that. Okay, I'll put this in as kind of a, so I've talked my piece on testing. This stuff is actionable now. Start putting into place plans for specifications, for logging. All of you should have a logging framework in mind, or get one soon. You might have a logging framework that can log to many different places at once. Good logging frameworks these days, there's good ones actually built into Java 8 and beyond. Good logging frameworks will support not only multi-level logging, like debug level, highly urgent events, and all sorts of things, and a spectrum of maybe 5 or 6 different levels of events, something along those lines. But good logging frameworks will also support putting information out to different sources, so logging to different destinations. What are a few destinations might log to? Yeah.
External server and internal memory.
Good. So I log locally, and I log to an external file server, maybe. What else? Might log to a console, right? Might log out to a console so I could see some information. How about another thing? Think about Oculus. Imagine log messages appearing in the viewer's views. You can see, oh yeah, okay. So a bunch of actions have been undertaken. Okay. So where else might I log to? We might log via HTTP. It actually post log messages to the mothership, right? What else might I log to? Database, ladies and gentlemen. Database. Might log to files, yeah. So there's actually many different destinations, and some of the good logging frameworks out there allow you to say, for this session, I want you to log to these 3 things. It'll sort of mirror the logs to, HTTP, I want to see on my console, and I want it to go to this database. So I have all those things preserved at different places. So that's good. So you should be thinking about logging frameworks, you should be thinking about assertions, you should put in place separation of concerns, you should have in place modularity that reflects that, specifications for your system, and you should be thinking over time what test hooks would be good to get into place. You should have a mocking framework picked out as well, and you should be thinking about ways that you could mock out, for example, portions of your system as a whole. Maybe it's, for example, the controller part. Mahmoud mentioned earlier MVC, for example. One of the nice things about MVC is you can mock out a controller and have the controller, which basically handles the user interface actions. That can be driven from a database, or it can be driven from a test script, or what have you. So instead of having the user click like this, it's driven by a test script which drives that automatically. Similarly, model view controller, you mock out the view, and you have the view instead be rendered, into a way in a file based on quantitative output or what have you. So start putting these things in place soon. I'm going to show you one graph here, and we'll finish. I'm going to show you one graph. This graph. This graph is from a series of U.S. space programs. The Voyager space program, the Magellan, Galileo. And this is weeks of testing on the x-axis. And this is cumulative number of defects found per 1,000 lines of code. Okay? Not surprisingly, these lines either stay the same or go up because it's cumulative. It's the number of defects they found per 1,000 lines of code over time. For a code base that's more or less static after these points. Take a note of this graph. I'll be posting it, and I want you to tell me next time, what are some features of this graph? What are some characteristics, and what does it tell us about software and software testing? Okay. Notice the time scale. Notice the counts, and notice how the shapes of these curves. There's a lot there, it turns out. after years of experience, right? This is getting out to the better part of a decade here from after they started to be tested. So I want you to think about this. We'll come back to it next time. Okay? That's all for now. Good luck getting started on your projects, and I look forward to seeing you on Tuesday.